In this video I'm going to look at finding the distance between two given points. So here I've got a point 3, 5 and another point that's 7, 15, and if you want we could have some axes on here. So this is quite easy. It's just an application of Pythagoras' theorem. So if I imagine drawing a line between the 2 points and then a perfectly horizontal line in the x direction and a perfectly vertical one in the y direction, that gives us this right-angled triangle, and we can use that triangle to work out this distance by Pythagoras. So the x distance here, it goes from 3 to 7, so that's 4 units, and in the y direction it goes from 5 to 15, so that's 10 units. So by Pythagoras we've got that this distance here, let's call it d for distance, d squared would be 4 squared plus 10 squared, so d squared is 16 plus 100, or 116, so d is the square root of 116. And if you wanted to work that out as a particular value, then you could do that as well. So I could say 116 square root, I mean as a decimal, so that would be about 10.8 to 1 decimal place, and or you might prefer to leave it in a third form. And if you're leaving it in third form, you could pull out a factor of 4 here to get 2 times the square root of 29 as well. Have a look at the stuff on thirds if you're not sure what I'm doing there. But principle, distance between 2 points, we just look at the x and y coordinates and apply Pythagoras. Just be a bit careful if you've got negative values in here. So let's say I've got -3, 8, and then -1, -7. That would be a bit further over here and down here, so -1, -7. The same principle applies. We're thinking about these distances, and actually, before all we did was took one coordinate away from the other and took and looked at the other and did that again with the other values. So we can really do that here. So this distance here is -1 minus -3, which is 2. Okay, -1 minus -3, so -1 plus 3 is 2, and this distance here is -7 minus 8, so that's -15. If you like, it's going down 15, but of course it's just a distance, so I can take 15 as the answer there. And so the distance here, d squared, would be 2 squared plus 15 squared, which is 4 plus 225, so d squared is 229, and so d is the square root of 229. You might want to leave that in a different form as you like, but that's how you work out the distance. Now, it might be informative just to write this out in a slightly longer form and see what we're doing, so we don't have to think it through every single time. What I'm saying is that the distance squared is the difference in the x-coordinates squared, which is -1 here, minus -3 all squared, plus the difference in the y-coordinates squared, so that's -7 minus 8 squared. Okay, so actually here we get 2 squared plus -15 squared, so it's fine to take this as -15 because squaring it's going to make it positive anyway, which is 4 plus 225, which is 229 as before. Okay, so now so what we're doing is taking one of the coordinates and subtracting, so looking at the x coordinates and subtracting them, looking at the y coordinates and subtracting them, and then applying Pythagoras. And notice it doesn't matter which way round we do this as long as we are consistent. So here I did this one, the coordinates for b minus a, and then the equivalent coordinate for b minus the coordinate for a. Okay, but if I did it the other way around for a, so had a and b the other way, what I would get, well, I'd have, so let's do it with a and b first. So I'd have -3 minus -1 squared, and then I'd have 8 minus -7 squared. So this is now so there's a bracket in there, -3 minus -1, which is -2 squared, plus 8 minus minus 7 plus 15 squared. So again I get 4 plus 225. So here I had a 2 and minus 15, here I got minus 2 and 15, but because I'm squaring them, it doesn't make any difference. So you can do it either way around, but you do have to be consistent. So in the sense that you have to take the difference of the x coordinates and the difference of the y coordinates. It doesn't really matter. Of course, it doesn't matter actually if you did, b and a, and then a and b here. I would just get 2 squared plus 15 squared. That would be the same thing. As long as you're taking the difference between the x coordinates and the difference between the y coordinates, adding them together, squaring, taking the square root, you'll get that. So let's say I wanted to find a distance between a general point and a certain point. So actually, okay, if I say I've got a point 27 and I've got some other point xy, well, I can do just the same thing. This distance here still follows Pythagoras. I just don't know what the values of x and y are here. So I have difference of the x coordinates, and let's do it this way around. So I get an x at the front. So x minus 2 is that distance there squared. Y minus 7 is this distance. Again, if you want axes on here, that's 2, that's x, so that distance is x minus 2, that's 7, that's y, so that's y minus 7. That would be equal to d squared. And I can't actually work out d here until I've worked out, until I know what x and y are. But I could say that d is the square root of x minus 2 squared plus y minus 7 squared. And this leads into a discussion of our next topic, which in another video, which is circles. Okay, but this is a general distance between a point and another given point. It follows the same formula if it's got algebra in it as if it were just numbers.